Okay, so we've been looking at the product rule, and I want to continue with that with this example here, except you might say this doesn't look like a product, this looks like I'm dividing, and it looks like a quotient. And we haven't learned the quotient rule yet. Okay, well, let's see what's going on here. G is going to be a differentiable function, obviously a function of t, so we know G prime exists. And we're going to find h prime of t if h of t is defined to be 7 times g of t divided by t cubed. So a couple things going on here. We've got one function written in terms of another function, so that's kind of new maybe for us for taking derivatives. But also we learned about the product rules we said, and this looks like a quotient. However, we're going to learn the quotient rule in just a minute here. But we don't need the quotient rule to do this problem. You say, how can we, this is a quotient, how can we get around it? Well, when I'm dividing by a single monomial, if you will, a single term down here, not a sum of two or more terms, then we can easily rewrite this, right? In other words, this is the same as 7 times g of t times t to the negative third power, right? I'm just rewriting that algebraically. So again, 90% of what we do here is algebra. You've got to be able to do this sort of thing very quickly. So notice dividing by t cubed is the same as multiplying by the reciprocal t to the negative third power. And now it is a product. It's g of t times t to the negative third power. So the derivative is going to be what? Well, first of all, this 7 is a constant multiple. I'm going to pull that 7 out, right? And I'm going to take the derivative of what's inside. Okay, so it's the derivative of the first function here times t to the negative third power plus g of t times the derivative of the second function. So this is constant multiple rule. This is the product rule again. This is a product rule. Okay. We're going to write this as a product, and we're going to use the product rule. Now, what is g of t derivative? Well, that's just g prime of t. Do we know g prime of t exists? Yeah, because g is differentiable. I don't know what it is. I know g of t is differentiable, and I know its derivative is g prime. So we just write it as g prime. T to the negative third derivative, that's power rule, right? Bring the negative 3 down. T, what do? I subtract 1. Be careful. Negative 3 minus 1, negative 4. Okay, and I'm going to go ahead and rewrite this without the negative exponent. This is negative 3 times what? The reciprocal of t to the fourth. So t to the negative 4 is reciprocal 1 over t to the fourth. So this is negative 3 divided by t to the fourth. So now I go back to the original format without any negative exponents. So I've got 7. And here I can rewrite this, of course, t to the negative 3 is again 1 divided by t cubed. So I've got g prime of t times this becomes g prime of t divided by t cubed plus what? I've got, well, sorry, it's minus actually because of this negative. Let me just write this as negative though. Negative 3 up top times g of t over t to the fourth. Okay. So then I can rewrite this. Let me clean this up a little bit. G prime of t over t cubed minus 3 g of t divided by t to the fourth. Okay, so that's one form I can put it in. Now, and that's fine right now. You may look in the back of the book, or if you're doing one of my problems, you might look at the answer, one of my non-textbook homework problems, and you'll see this as the answer. I hope everyone knows how to go from here to here. I hope you understand how to go from here to here. What's happening? What did I do? How did I get from this thing here to here? Obviously there's the 7 still outside there. What did I do? I just combined, I subtracted these two things, right, by finding what? A common denominator. What's the common denominator between t cubed and t to the fourth? The least common denominator is t to the fourth, right? So I need to multiply top and bottom of this fraction by t. So there's t times g prime of t times t cubed is t to the fourth, and this is already over t to the fourth, so then I can just subtract. So hopefully you understand this is finding a common denominator and subtracting. Okay? So being able to simplify rational expressions, adding and subtracting them, that's an intermediate algebra skill. You've got to have those skills down. Okay, we'll circle this one as our answer. But again, so work on the simplification. That's, you know, a lot of times that's the problem we have, is just simplification problems, and you've got to be able to be careful to do that correctly. Okay, so we've been looking at product rule. I want to look at one more example involving the product rule, and this time I've got a function m of x, and it's a product of 1, 2, 3 functions, and we'll assume they're all differentiable. Find m prime of x. Okay, I'm going to use the product rule, but the way I'm going to do it, you say you have to have two functions. I've got 3 here. I'm going to group the first 2 together as one function, and then I'm going to have this h of x as my second function. So I'm going to use the product rule here. So m prime of x is the derivative of your first function. And the first function is a product of 2 functions, so let's put those in a parentheses, and prime, right, take the derivative of that, times h of x plus f of x times g of x times h prime of x. I don't know why I got these extra brackets out here, but I did for some strange reason. I don't need those extra brackets. Okay, so it's the derivative of the first one, which I'm calling the product of 2, times the second, plus the first, which is the product of those 2, times the derivative of h, which is just going to be h prime of x. Okay, but now when we look at this right here, what are we looking for? The derivative of f of x times g of x. This is product rule again. So I've got a product rule inside a product rule. Right. And so what's this going to be? What's this product rule going to be? It's going to be derivative of the first, which is f prime, times the second g of x, plus the first times the derivative of the second. And don't forget times h of x. Right. And I still have this part over here. And then just to simplify or write the final answer, I'm going to go and distribute this h of x through. And then times this last one. Now, there's our answer. So having product rule inside of product rule gets a little messy. What if we had 4 functions, a product of 4 functions, or 5 functions? How could we find their derivative? You'd have to you'd have an extra product rule in there, you know, somewhere. So you would have to break them up in a certain way to do that, and that can get kind of tedious. But look what we've got here. Do we see a general trend here? Look at our answer from the original. Can you look at this, and can you say in words how to find the derivative of a product of 3 functions? Can you say that in words? Well, I'm going to tell you what I would say in words. The product f of x times g of x times h of x, its derivative is found by doing what? Take the derivative of the first function, f, times the other 2, and then take the derivative of the second function, times the other 2, and then take the derivative of the third function times the other 2, and add each of those products up. That's the product rule. And it's consistent. You know, when you had 2, that's what we did, right? Take the derivative of 1 times the other, plus the derivative of the other times the first one, right? Add those together. That's the product rule. So if you had four functions multiplied together to find their derivative, you would do what? You take the derivative of the first one times the other three, derivative of the second one times the other three, derivative of the third one times the others, derivative of the fourth one times the others, and you would add those four products up. And there's your answer. So you wouldn't have to go through this long process of product rule inside a product rule. So it's kind of neat to remember that. That's helpful at times. And I wanted to show you that. Okay, so product rule, very important. Equally important is the quotient rule. Now I'm just going to give you the quotient rule. I'm not going to prove it. Okay, we could prove it, and later on we can prove it after we look at the chain rule as well. But we will just go ahead and state it. It's not too bad. It's a little bit more involved, obviously, than the product rule, which kind of makes sense when you think about quotients being more difficult than products. So if f and g are both differentiable functions, then the quotient f divided by g is differentiable for all x such that g of x is not equal to 0. So notice we have to make sure the output to the function g is not 0, otherwise the division problem would be undefined. And here it is. The derivative of f of x divided by g of x is f prime. Sometimes we say f is the numerator, but for short the top function. G of x is the denominator or the bottom function. So top, bottom. It's the derivative of the top times the bottom, right, minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, so it's a little bit of work. But if you look at the top almost looks like the product rule, except there's a subtraction instead. And so let's take a look. Here's that product rule as a reminder. The form is almost the same. F prime G, F prime G, FG prime, FG prime, but there's a minus instead of plus. Now, here, with the product rule, does it matter the order that I do these two in? No. I could swap the order. Adding 1 plus 3 is 3 plus 1. Both 4, right? Doesn't matter. But is 3 minus 1 equal to 1 minus 3? No, it's not. Right? In fact, they're just opposites. Okay? So, one way that there's lots of tools. I've heard of little sayings to help you remember these, the quotient rule. You will need to know the quotient rule. It will not be given to you. You will need to know it later on when we take the derivative of functions. The way I remember it is this. Let me show you how I remember it. I think of this function here, 1 divided by x. Okay, and I already know the derivative to this function. H prime of x is going to be what? Well, I would first rewrite this as x to the negative 1 power. 1 over x is the reciprocal of x. It's just x to the negative 1. And by the power rule then, this is negative x, subtract 1 from negative 1 to the negative 2, which is negative 1 divided by x squared. Okay? Now, I know that already, but if I wanted to, I can go back and check my quotient rule to make sure it's right, because if I'm subtracting in the other order, what would happen instead of getting negative 1 over x squared, I would get what? Positive 1 over x squared. And you can see this is going to work because here f is the top function is 1, g is x. So obviously I've got g squared, so that's x squared, the bottom's right. But then notice this, the top is 1, what's f prime? What's the derivative of a constant? 0. This thing goes to 0, and I'm just left with f of x, which is 1. G of x is x. Its derivative is what? 1. I get minus 1. 0 minus 1 is negative 1. And this gives me the correct response. If I had this order incorrect, right, if I had this order incorrect, I would get 1 minus 0. I'd get positive 1 over x squared. Since I know the derivative has to be negative 1 over x squared, I would know my formula for the quotient rule is wrong, and I would change the order. So it is important that you get the order correct in up top here. Okay, let's take a look at this first example. Here is a quotient that I cannot really simplify down. You remember I did an example where I did simplify because there was a single monomial term that I could divide both the 5x and the 3 by, but here I've got two terms. I can't do that easily enough. I'm just going to go ahead and use the quotient rule. So the derivative in this case is going to be, so here's my top function, 5x plus 3, that's the f of x, g of x is the bottom function. So I've got the derivative of the top function times the bottom minus the top function times the derivative of the bottom. All divided by what? The bottom function, x squared minus 1 squared. Right. Now, what is the derivative of 5x plus 3? Well, the derivative of 5x is 5. The derivative of 3 is 0. So I get 5 plus 0, which is 5. What's the derivative of x squared minus 1? Derivative of x squared minus 1 is 2x. Right? Derivative of x squared is 2x. Derivative of 1 is 0. So we should be getting real quick with using the power rule by now. And so if I clean this up by distributing, right, distribute this 5 through, and be careful, I'm going to distribute the 2x through, but I've also got to distribute this negative 1 through. So when I simplify, I get 5 times x squared. 5 times negative 1 is negative 5. And then negative 5x times 2x. Negative 5 times 2 is negative 10x squared. Negative 3 times 2x is negative 6x. And then I can combine like terms. 5x squared minus 10x squared is negative 5x squared. Minus 6x minus 5 if I want to put it in descending order. Okay, and there's the answer. Let me just say this. Sometimes, when you're checking answers, if you're in the textbook or looking at someone else's answer, and you might see some things that look a little different. Like, for instance, what if someone had written this as the answer? Put a negative sign up front and written it as 5x squared plus 6x plus 5 over x squared minus 1. Would that be the same thing as what I have in the box? You betcha it would be. What I've done basically is factored out a negative 1. Right? So negative 1 distributed through all this. So if you just have the negative 1 out here in front of the big fraction, usually they don't put parentheses around it, that means it's negative 1 times all this stuff. So there is really a parentheses around this numerator, don't forget. And we don't usually write it, but that is the case. Okay, so just keep that in mind. Again, manipulating expressions algebraically a lot of times happens. Okay, let's look at one more example here. Again, this one I cannot simplify down very well. So I'm going to go right into the quotient rule. This just says find the derivative with respect to t of this function. So I don't need to do any special work here. We'll just take the derivative. It's the derivative of the top function times the bottom minus the top times the derivative of the bottom, all over the bottom function squared. Now, the derivative of e to the t, what's that? Notice it's e to the t, e to the variable, t is the variable. We know that's just e to the t. That's the easy derivative, right? The derivative of e to the t, the exponential function, is e to the t. E to the t derivative is e to the t. Derivative of 1 is 0, so I just get e to the t for the derivative there. Now, let's distribute. E to the t times e to the t is e to the what? Add t plus t, 2t. Not t squared, 2t. E to the t times 1, e to the t. And then minus e to the t times e to the t is minus e to the what? 2t again. Do we see how the top simplifies down very nicely? This minus this is 0. I'm just left with e to the t over this. And there is the derivative using the quotient rule. Okay. So we'll stop here. In the next video we'll sort of finish out the quotient and product rule and look at some other examples. Typically, quotient rule, it's not too bad, but if we can avoid it, if we can simplify first, and then take the derivative after simplifying, sometimes that's better. In these two cases that we just did, that is not the case. We have to use the quotient rule, and in fact we want to, and it's not that bad. Okay.